Who can remind us what we use to ask questions in our code? If you remember correctly, we use conditionals. So starting with this lesson, we're going to learn how to make our conditionals more powerful and our code more efficient. If you don't have your Canvas open, make sure that you open it so you can add these terms to your ePortfolio. So we're going to complete a little activity called Who's That Student? And obviously this looks a little bit different because I am talking to myself into this video as opposed to you guys sitting here doing this. So what we would do is look at this survey, and then we would simply, for each statement, we would check true or false if it was true for you personally. And then as you finish, there would be one person, or I shouldn't say one person, less people standing, okay? So let me just run through this real quick. I need everyone to stand up right where they are. I'm going to read a series of statements. Listen carefully, and as soon as you hear a statement that is not true for you, please take a seat and remain seated. And that's when you would go through those, and again, at the end of the round, you would have a seat. So what happened as soon as a statement was false for you? You probably sat down, right? Did you stand up again when you heard something that was true? No, because once you sat down, you had to stay seated, okay? So this is where the Boolean comes in. And remember that a Boolean is simply a true or false value. Booleans are a new data type. If you remember, you have other data types. You have a string, you have an int, and you have a float. And now you have a Boolean, which is a true or false statement, or true or false value, rather. All of the conditions we've written in other activities actually create a Boolean. Those conditions are Boolean expressions, meaning they are expressions that create a Boolean value, meaning true or false. So what is the Boolean value of the condition 5 is less than 10? That would be true. The Boolean value of 5 is equal to 3 would be false. Okay, so we're going to explore a sample program in here. We're going to look at part 2 math. And if we run it, what does this program do? You can see it's asking you a few math questions. You can type in the answer, and it gives you some response to it. So, how does this if condition work? Okay, so correct is true if the user entered the right answer. True is equal to true, then tell the user they were right. Okay, so take a minute and go ahead and experiment changing up the numbers in the question, what is 2 plus 2, and see how that changes your answers. Also then, try to change the elif clause to an else clause and print the correct answer if the user guesses incorrectly. And you might want to pause and do that, and then come back when you finish. So the pieces of code in red here are Boolean expressions because they use comparison operators to produce a true or false value. Like we saw in that program, we can assign a Boolean expression to a variable. What would the value of bool 1 be based on the Boolean expression 5 equals 5? Well, it would be true. What would the value of bool 2 be based on the Boolean expression num1 is greater than num2? In this example, that would be false. Okay, so then we have a logical operator. This combines or modifies a Boolean. And those particular logical operators are and, or, and not. So just like the plus operator lets us combine two numbers or two strings, and or are logical operators that let us combine two Booleans into a new Boolean. Unlike our other operators, which use mathematical symbols, logical operators use normal English words. Not is also a logical operator, but it's a little bit different. It changes a single Boolean. We can use more than one logical operator at a time, but let's start by looking at them individually. Okay, so the and operator, it's true if all parts are true. So true and true equals true, true and false equals false, and false equals false. If even one part of a Boolean expression using and operators is false, then the entire expression is false. More than one part can be false, and the expression is still false. Using and is like our starting activity. You were standing up only if every statement was true for you. As soon as any statement was false, you sat down, and the complete set of statements could not be about you. For example, if I am old enough and I have a driver's license and I have access to a car, then I can drive a car. If any of those are false, then I cannot drive a car. Just like if you complete your chores and you finish your homework, then you can watch TV. If the basketball goes in the hoop and I was standing behind the three-point line, then I get 3 points. The or operator is a little bit different. True if one or more parts are true. So true or true is true, true or false equals true, false or false equals false. So even if one part of a Boolean expression using or operators is true, then the entire expression calculates to true. More than one part can be true, and the expression is still true. For example, if I am grounded, or I am babysitting, or I am too tired, then I can't go out tonight. That's true if one, two, or all three of those parts are true. Other examples could be if you have math homework or have science homework, then you need a calculator. If you have a key or the door is unlocked, or if someone is home, then you can get into your house. And then finally, you have the not operator, and this just gives the opposite Boolean value. So if you say not true, that means it's false. If you say not false, then that's true. The not operator changes the value of a single Boolean by taking the value and returning the opposite value. If the value is true, the new value is false, and vice versa. What is the value of each of these Boolean expressions? High equals high, and 4 equals 4. That is true because both parts are true. Ands equals Y, or ands equals yes. True because the first part is true. Play again equals true. Not play again. That would be false. False, because play again started off as true. Let's go ahead and open the Part 3 vacation destination. And let me close that up so you can see better. Okay, so in this program, we'll suggest a vacation destination for our user based on their preferences. We'll choose a destination based on whether the user wants to be near the ocean, what temperature they prefer, and if they want to see exotic animals. So directly underneath let me change the font size, under the Brazil comment, directly under the Brazil comment. So that is right here. We are going to add this if statement. So if ocean equals true and hot equals true and animals equals true, then you should go to Brazil. Okay, now you have one for the Uganda statement right here. And just notice that I did indent one time for each of those because it is nested under this if statement, okay? So elif hot equals true or animals equals true, then go to Uganda. So why do we use the elif here instead of an if? We only want to recommend one destination, so we don't want multiple conditions to be true. The program will recommend Uganda if ocean is false, but will recommend Brazil if ocean is true. Now, directly underneath the Russia comment, before the print statement, we can put our last one in here, which is going to be an else, because anything other than those things tells the person that they should visit Russia. Okay, whoops, wrong one. Let me go back here and to the slides. Okay, so on this, we have if A equals true, if B equals true, then do X. So this is basically saying if A equals true and B equals true, do X. So we've learned how to use logical operators to reduce the number of conditions we need in our code. Let's review the way we previously combined conditions here in blue and the way we learned today here in red. One student reads the blue code aloud, another is going to read the red. Try that with a partner so that you guys can compare what is what. So they both do the same thing, you just have a nested if statement, whereas the one in the red is using a Boolean statement there. So again, here we have two if statements, this time not nested, but rewritten. You have if A equals true or B equals true, then do X. Another, a simple if statement, which turns into if not A equals true, then do X. So we haven't used not very much yet, and if you're thinking it's really doesn't really seem any better, I'd probably agree with you, but we're going to learn something called Boolean Zen in an upcoming lesson, and that will help us see the real benefit of using not. For now, you just need to remember that it gives us the opposite Boolean value. So some things that you guys need to think about. How can we ask more complicated questions without our code getting too long? And how can we understand different responses from our users? So we have compound expressions, Boolean Zen, input flexibility, okay? And we want to reflect on how logical operators make our code easier to understand. And then imagine you're making a photo sharing app. What are two examples of data you could store as a Boolean?